Hello. I hope you can hear me.
So you can start the presentation now.
Thank you. I'll just make this work. I hope you can see that now. Could somebody confirm, please? Good. Good afternoon, everybody, and thank you very much indeed for the opportunity to speak to the event today. I'm going to tell you something about what is going on in Orkney, which is a small island off the north tip of mainland Scotland, and really what EMEC is doing as an organisation which is being a catalyst for change and finding a way to pioneer the new clean energy future that we all know that we need. So EMEC was set up very much as a means to try and find a way to harvest energy from the sea. And over time, we have grown our mission from just working on wave and tidal energy to being a pioneer to a transition to a clean energy future. What we're trying to do is act in a way that helps people bring their ideas forward. So we don't necessarily design or create ideas, we help other people bring their ideas along. And I'll show you in a few minutes about how we do that. But our mission is very much to find a way to get these ideas to work and do that as quickly, so reducing the time, the cost, and the risk for these technologies to get to market. Because we all know we need these technologies to work, and we need them to work very soon. So why are we bothering to work on marine energy? Well, this is a graph that was produced some time ago by OES, which looks at the wave energy intensity around the globe. And effectively, you can see that the orange and red colors are where there are strong waves. And together, there is an enormous amount of energy in our seas. We believe that that resource is accessible in a variety of ways, and it's either as wave energy or tidal energy. And those numbers don't mean much on their own, except when you look at Europe's electricity consumption, you'll see that the amount of energy from wave is much greater than Europe's energy consumption. And indeed, it's about twice what tidal energy is about half of what Europe actually needs. So this is a considerable energy source, if only we could find a way to get at it. We know it is carbon free, and we know that because the energy is very close to our own shores, that there is a great security of supply opportunity. We also believe that wave energy and tidal energy complements other renewables because, unlike solar, it works at night, and often wave energy happens sometime after wind. So we know that these energy sources can fit together, and as we create a more renewables dominated energy system, having a different form of energy is actually going to be quite important for that diversity of supply. And naturally, of course, if we can make this technology work, or when we make this technology work, we'll create new industries. There'll be new work to be done, new jobs to be created in areas which sometimes don't necessarily have a large amount of natural indigenous employment. So we see this as fundamentally important and something that the planet as a whole needs to engage in, which is why we're very keen to talk to countries all around the world who have got coastlines and also the production facilities to be able to produce the machines that we know we're going to need in the future. Because there are jobs to be had in creating this industry. And we know that there are exports to be created, not just from the UK, but from South Korea and so many other industrial nations who do excellent work in the sea. So the UK resource is considerable. We reckon that the UK has around about a third of Europe's wave energy potential, and we reckon we have about a half of Europe's tidal potential. And I said Orkney is a small island just at the top, and that's where we are. So the energy potential is shown on these graphs was really discovered from work done by the UK government back in around about the turn of the century. Will you excuse me? I just have a slight cough. I need to deal with this. Give me a second. Forgive me. So the UK government discovered where the energy exists around our waters. And certainly the north of Scotland is an area which has got both strong waves and strong tides. And it's no surprise, therefore, that people in the area decided to try and find a way to harvest these and find and see if there are technologies that can be created that will actually bring this energy to shore. So why do we actually do it in Orkney? Well, we have a large amount of resource. We have very, very strong tides, and we have very, very large waves. The largest wave we recorded on our test site is 18 meters high. On our tidal site, we have water speeds up to about 4 meters a second. We are the most northerly point on our national grid, and we also are blessed by having good local harbours into which we can bring ships and bring equipment for the operations. And we also have a long-standing heritage of working on renewables. This is really because over time we have worked on onshore wind, and people have been very committed to trying to find a way to a low carbon future. So we have a lot of people who are actually got expertise in working in energy and renewables, and also the marine skills of diving and fishing and various other things in the sea. And also we have an understanding of our environment. So together, we believe these things form an opportunity to make the most of the energy potential that we now know exists around our oceans. So the island itself, the group itself, we have offices. We also have our test sites, and there are two main ones and two smaller ones. So we have our wave test site on the extreme left-hand side. You may be able to see my cursor, which is here, and the main tidal test site, which is in the middle of the island group off the little island of Edy. And then we have small scale tidal site and wave site, which I'll talk more about those in a moment. In addition, the infrastructure has been boosted to help renewables. And I have to say, we are only able to do this because of the very strong supply chain that both existed in Orkney before we came here, but also has grown as a result of the work that's been going on with marine renewables, of which we've been a part. And we like to work very closely with the local supply chain. And we would argue that's fundamentally important. These technologies will only ever be an idea unless they're adopted, and adopting the technology requires the local population to really want this to happen. And we're pleased to say that's exactly what has happened in Orkney, and it's something that we think is very, very strong in all other island communities. So that's what we have in the islands, but actually specifically on the sites, we have effectively the same model, which is of cables that run from the sea to the shore, and developers come and put their machines onto the ends of the cables. The electricity flows down the cables, as you can see there in the red lines, and those cables then come ashore to a substation, and there is then instrumentation at sea, which measures the performance of the machines to gauge which is the best one to deploy further. The left-hand side was built in 2004. The right-hand side was effectively mainly built in around 2005, and was then both of them were extended in 2010. So our scale sites, as I mentioned, we have are also designed to try and help people bring smaller scale machines to the site. And these comprise concrete blocks which are on the seabed, which allow us to help people install small machines which can either be on the surface, in midwater, or on the seabed, depending on their technology and what they're trying to do. And we have a means by which we can monitor the electricity and then send data back to our sites to experiment, to allow people to record the data. And we see these sites very much as opportunities not just to install machines, but also test techniques, test the ways in which different machines can be operated in these sites. And that's been very successful so far, looking at a variety of projects, which I'll touch on a few minutes later. So there are a number of different ways in which the energy can be absorbed from the sea, and these graphics are on our website, and feel free to look at them later. But effectively, wave energy works by the motion of the water, and it's the surface we tending to be interacting with, i.e. the height that's created, the potential energy in the waves, and in the tides, it's the horizontal flow of water. Now, in fact, most of the machines we've seen installed fall into the top left-hand category of horizontal axis machines. And I'll show you a photograph of a couple of those now. But there are a number of ways in which energy can be extracted from the sea, and we firmly believe that different ideas will be tested, and eventually the best will emerge to the top of the pile. And over the years that we've been operating, so far we've installed or had installed 35 different devices from 11 different countries, from 22 different developers. And the photographs around the outside show something of the different types of machines which have been installed. And it's a very, very exciting space. It's very, very exciting to see people trying these new ideas out and finding ways to make this all work. So we are privileged to be able to be in a position where people want to come and try their machines with us. So these machines work really well, and in Orkney right at the moment, there are 3 machines in the sea. The one in the top left-hand corner is by a company called Orbital Marine Power, which is a 2-megawatt tidal turbine, just over 2-megawatt tidal turbine. I think it's around 74 meters in length. And the 2 blue arms, the one that has O2 written on it, and those arms hinge downwards into the water, taking the red rotor blades you can see down into the tidal flow. The one on the top right-hand corner is from a company called Magallanes, who are based in Vigo in Spain and have also moved now to Scotland, which we're pleased about. That too is a machine with rotors, which in this case the 2 rotors are one behind the other on a deep keel, which is underneath the machine, and that's rated around about 1.5 megawatts. And in the bottom is a wave energy machine from a company called Motion Energy, which is a hinged raft, and that machine has been tested on our site, is now being tested on another site nearby, and we're looking forward to welcoming them back. The point is there's a lot going on. There are ideas being tested for real, and these machines are being maintained at the moment, and our 2 tidal machines are being maintained. They're going back on site very shortly. But it's not just about what's going on in EMEC. There are a lot of other things going on around the rest of the UK as well, and we're pleased to be playing a key part in that where we can. For example, the machine in the bottom right-hand corner is on an adjacent site called Maygen, and the 2 types of machines that were installed there were both tested on our tidal test site originally. And we believe that the process that people are going through is actually fundamental, which is really about there are the 5 main stages, which leads to a 6th item, which is: can you install the machine? Does the machine survive? Is it reliable? Can you maintain it? Does it operate in a real energy system? And if you can answer yes, or you know the answers to all of those questions, you will then have the answer, which is it cost effective? And cost effectiveness is going to be fundamentally important to be installing these machines in the future. And the point of a test site is it should help people answer these questions and get to a point where cost effectiveness is nearer than it would be otherwise. And I said something about the real sea challenges and lessons that we have learned. We've seen very much that the sea is a hard place to work, which anybody who's used to work there, it would be no surprise. Top left-hand corner is a photograph of a camera system, which was on one of the devices, and you can see how much marine growth has been across the lens of the camera. It is going to be the small details which make life difficult. Top right is about the seabed. People often think the seabed is fairly flat. In fact, it is everything but flat, with some areas of great sills, some areas of huge rocks, very, very site-specific. The bottom left was really to indicate how harsh it is at sea, and the one time that you discover a machine is struggling with the weather is probably the very time that you cannot go and intervene with the machine because the weather is too bad to go. So it is a place where you have to be very prepared. And in the bottom right-hand corner is a track the tracks of vessels on one day on our site when a lot of installation work was going on. And we can see from a health and safety point of view, controlling the vessel movements is going to be very, very important in areas which are going to become very congested with marine energy machines. So we get involved on a whole lot of different projects, from environmental monitoring, installing subsystems, trying different tools out that people are using, and indeed looking at the components. And on the bottom right-hand corner was a company who were installing different paint systems to test. And we believe getting marine energy to work is more than just getting a single machine to operate. There is a lot to be done. There are a lot of tests to be undertaken. There are a lot of components to be designed and a lot of things to be discovered. And that's really what we try and help people do. And we were pleased to say that we even had an unexpected visitor, which was Microsoft came and did work with us when they installed an underwater data center on our site. And the point there is that we were setting up to work on wave energy, and people came along with a way to use that wave energy, use that energy in the sea. We were delighted that NATIC, the project NATIC, was hosted on our site for nearly 2 years, I believe. So finally, the bit I want to talk about was just about international collaboration last couple of minutes. And this photograph I took when I was in Kamishi in Japan, which shows exactly the danger of not having good standardization on an international basis. Here we have 3 electrical sockets, each of which was designed in isolation. And consequently, we all have to travel around with a pocket full of converters to move between different countries. We can do better than that, and marine energy really needs to have a uniform series of standards. So we've been very keen to help develop both testing standards which will aid consistency and have complementary research agendas which will then find our way through these problems. This is not a problem that Orkney is going to solve on its own and Scotland's going to solve. It's going to be a problem that gets solved or attacked on a wide front by a number of different countries. So we've been working on the standards and testing. Also, we're very keen to help standardize on environmental monitoring and the resource characterization and the data analysis, so that when people come to a conclusion or an answer with something, we're confident that everybody's getting the same answer. And then finally, we're really helping other test centres with their governance and other activities. And to that end, we run an organisation called International Waters, where we bring people together from different test centres to discuss various issues that are going on. And this was a photograph taken only a month or so ago in our office in Orkney. And we were really pleased to welcome 3 delegates from South Korea, Dr. De-Yong Park from CRISO, Mr. Dong Hui Ko from KIOST, and also Mr. Gilong Kim from CRISO, all of whom came all the way to Orkney to see what was going on. And I hope everybody got a lot out of the events, because there were a lot of discussions which went on to work out exactly how to do these various complex things. And by sharing our respective experiences, I'm sure we have helped move the process forward and helped everybody in their individual research agendas. So we'd seek to collaborate globally because we know this is a global initiative. And as I said earlier, this is an initiative where the energy is all across the globe, and it's really important we find different ways to help these different governments work together and find a way to harvest the energy. I'm going to stop at that point because I'm conscious of time, and I'll be very happy to take any questions at the relevant time. Thank you very much indeed again for the opportunity to come and speak to the Ocean Tech Conference. Thank you.
Thank you. Thank you for your presentation.